Welcome to the 6th video on the Unit 12 playlist of our Chemistry Matters series. In this video, we'll provide a quick recap of the content covered in Unit 6, Stoichiometry. In Unit 6, we investigated one of the most useful tools in all of science, the mathematical tool of dimensional analysis. Also called the factor label method, dimensional analysis utilizes equivalence statements as conversion factors. We discovered that by carefully following the dimensional analysis steps, we can solve any stoichiometric problems. The primary reason for understanding such conversions in stoichiometry is to allow us to predict and measure the outcome of any reaction. Stoichiometry is vital in research, as well as in the production of new chemical materials. The central value in stoichiometry is the mole, a name we give to 6.02 times 10 to the 23rd particles. 6.02 times 10 to the 23rd is known as Avogadro's number. In the same way that a dozen of any substance equals 12, 1 mole of any substance contains 6.02 times 10 to the 23rd particles, whether they're atoms, molecules, or formula units. We learned that molar mass is the mass in grams of a mole of a substance. Starting with that simple concept, we learned how to do several primary types of stoichiometric conversions: moles to atoms, atoms to moles, grams to moles, and moles to grams. We also explored molar volume conversions with gases, because 22.41 liters of gas at standard temperature and pressure equals 1 mole of that gas. These stoichiometric calculations reveal the extremely tiny size of atoms. We learned to determine empirical formula, percent composition, percent yield, and the molecular formula of substances by performing stoichiometric calculations in balanced chemical equations. Our lab activity on limiting and excess reactants involved the manufacture of s'mores. And we demonstrated what happens when you don't have enough of a reactant to fully complete a reaction. Our students also completed a performance task using stoichiometry to calculate the balanced chemical equation for the combustion reaction of hydrogen and oxygen rocket fuel, ultimately launching miniature rockets across their classroom. Finally, to help summarize all of this content and confirm our understanding of why chemical reactions matter, we spoke with Dr. David Gottfried of Georgia Tech's Nanotechnology Lab. Remember, our toolkit has a document on which you can find a list of the Georgia science standards addressed in Unit 6. And please join me for the next video on the Unit 12 playlist, recapping Unit 7, Solutions, Acids, and Bases.